So today is 29th, right? 1 over x.
Plus 1 over x plus 4 equals 1 over 4.
Good. Okay, so this is a rational equation, and we're trying to solve it. I'm going to use the method that I used last time. If you know a different method, you can use your method. So 1 over x plus 1 over x plus 4 minus 1 over 4 equals 0. And I do have to state two restrictions. And those restrictions are, yes, 0 from here. Careful. So we write x plus 4 not equal 0. When we move a term from one side to the other, we change its sign. So it has to be not equal negative 4. Is that clear? Perfect. Now we find what? Now notice that if I don't write the fraction line, the equal symbol in 0, I may forget the right-hand side, and then I will not solve. Always make a note to redo the problems we do in class first. That's your first step towards understanding any of this. Okay, now let's find the least common denominator. Can I factor x? No. Can I factor x plus 4? No. Can I factor 4? No. So then how many different factors we see here? 3. All of them have to be in LCD. According to that, we have to find the adjustments. I like to call them the adjustments for the tops of those fractions. Can anyone give us the adjustments for each? If it has x and it doesn't have 4 times x plus 4, the top has to take 4x plus 16. If it has x plus 4 and it does not have 4 and x, the top has to take what it does not have in the denominator. Can anyone give us the top of the third one?
X squared plus 4x.
Excellent. So it has 4, so it has to have this. The reason I put it up there already distributed is because of cutting back on writing a little bit. Okay, now can anyone give us the numerator of this fraction?
Four x plus 16 plus 4x plus x squared plus 4x.
So we are distributing -1
Oh, negative, so,
to two terms.
so minus x squared minus 4x.
Perfect. So the -4x with the positive 4x, now I have to combine like terms. And now I rearrange everything in descending order. So -x squared plus 4x plus 16 divided by 4x times x plus 4 equals 0. Any questions so far? So now, if you want to do the elegant way, you'll say a fraction is 0 when the top is 0. -x squared plus 4x plus 16 equals 0. Of course, you will multiply both sides by -1 because we should always refuse to solve any equation, especially a quadratic equation with a negative leading coefficient. Is this okay so far? Yes?
How did you get to the quadratic by itself?
I copied -x squared, I copied 4x, and I copied 16.
And then how'd you get rid of the denominator?
4 apples. You have 4 apples, you give them to me.
The denominator, it's in red, and then below it's just a quadratic.
So-
Equals 0. How do you understand?
So I copied the 0, I copied the numerator in descending order, and I copied the denominator.
And then below it, how come it doesn't have a denominator?
Okay? A fraction is 0 only when the top is 0. A fraction is 0 when the top is 0. or you cross multiply. This times 1 equals this times 0. So we multiply. Please stop me if you have questions. X squared minus 4x minus 16 equals 0. And I was looking back, I think we solved this problem, didn't we? Because we used the quadratic formula to solve it, I thought. And maybe yes, here it was. So this was what we did last time. So then x squared minus 4x minus 16 equals 0 is not factorable. So then we use the quadratic formula to get this. Is that okay? Is that good enough, Ben?
Yeah.
Or you want me to continue?
No, from this point on, I can do it.
Okay. Okay.
Thank you.
Perfect. Other questions? Next question. So I'm going to write continued last lecture. Okay. Next question. Anything else you would like me to look at? Any other topic that you looked at and you would like to continue with? If not, I would like to summarize those 4 different methods of solving quadratic equations. Bless you. Yes, please.
How do you know when to write when you're factoring? How do you know when to do a difference or something?
When I factor a binomial, you mean, or a trinomial?
Well, here I wrote right here the things that's different. But it's any further to figure out. I'm supposed to write
Let's
this.
do that. I want to explain that. So let me copy that. So 9x squared plus 21x minus 8. Very good question. So 9x squared plus 21x minus 8 equals 0. So this is what I was planning on showing you or summarizing anyway. So this is solving quadratic equations. Quadratic. Solving quadratic equations. Okay. So let's suppose I'm given this equation and I'm asked to solve it using the method of your choice. I have 4 ways, possible ways. We only talked about the first one, which is factoring, and we talked about the last one, which is quadratic formula. We did not talk about the middle ones, the middle 2 ways or methods. So I would like to show and try factoring. Here's my theory. If I'm given this equation and I'm asked to solve, which method of the 4? I haven't even mentioned number 2 and number 3, but disregard that for a moment. Which of these 4 methods will I use? There is one in specific that I'm going to talk about in a few minutes that is very specific. You can miss it. That's one option. The third one, which I'm going to mention in a few minutes, never. I will never use that one. I'll tell you in a minute. I will never use it ever unless you force me to, and I'll explain why. So then I'm down to 2 methods, either factoring or quadratic formula. If factoring takes more than 30 seconds, I'll say forget it. Use the quadratic formula, and I'm done. I don't want you to sit there with huge numbers and start to figure out, okay, which 2 numbers multiplied give this, and added or subtracted give this. No. Okay? So in this particular case, with these numbers, I would have, unless I'm forced to factor, I would have used the quadratic formula. But let's suppose we are forced to factor. We are told you can only use factoring to solve this problem. Okay, fine. In that case, remember, it's in descending order. It's a trinomial, no greatest common factor, no negative leading coefficient, no special product. Negative 8 is not a perfect square. 1 is not the leading coefficient. So we are down to the very last possibility. What is the last possibility? When we multiply and we get 2 the product of two numbers to be negative 72 and whose sum is 21. I don't like negative 72. Negative 72 is a huge number. However, it's negative. Therefore, I know for sure that I am looking for a positive and a negative. Would you agree so far?
Yes.
If the product is negative, one number has to be negative and one number has to be positive. So far, so good?
Yes.
Perfect. So then I'm trying to find those two numbers. And I have 72, which is 8 times 9. This one is 2, 2, 2, and this one is 3, 3. So I'm looking at 72 as 2, 2, 2, 3, 3. So from here, I want to come up with two numbers, one that is positive and one that is negative, using all factors. And when I add these two, I get positive 21. When I add a positive and a negative and I get 21, they must be kind of apart. If I add them when I get 2, they have to be close to each other. But if I add them and I get 21, they are kind of, one is small and one is big. So the difference between them has to be 21 units, right? So let's see what we can do here. So 9 times 2 and then 4 will not work, right? Then what about 3? So what about 12 and all I'm trying to obtain is a 21. So if they're kind of apart, right? So 8 times 3 and 3. So I found that this number is 24 and this number is 3. So when I multiply them, obviously I get 72 because I used everything. So when I multiply these two, I have to get 72. And when I add those, I have to have 21. So now I know for sure that this must be the positive number, this must be the negative number in order to get the 21. Does that answer your question somewhat?
Yeah, I ended up figuring it out.
So this is 9x squared and plus 24x and minus 3x and minus 8 equals 0. So it has to be this. You can put them in the opposite order, but it doesn't matter. The 3 has to be negative and the 24 has to be positive. Because this is the only way to get to the positive 21. Does it make sense? You can not write this particular sequence. Either negative 3 plus 24 or 24 minus 3 because this is the only way to obtain a 21. Does that answer your question?
Yes.
Okay, perfect. So next step, of course, I will factor by grouping. What do I factor out from the first two? Not only.
3.
Yes, perfect. And what is left in parentheses?
3. X
Yes,
plus 4.
plus
Plus
8. I have to get a 3x plus 8. I refuse to look. Who knows? I may copy something wrong. I may factor a different number or factor where the sign is wrong. Who knows? Especially in a heated situation. I'm on a test. I'm giving a test, and I will definitely copy it first, and then I look. Oh, okay. Never mind. It's okay. And now from these two terms, what do I pull out? Plus 8, and what is left in parentheses? I have to have two terms. One coming from the first term and the other term coming from the second term. That's how my markers get dry. They dry out. When I wait for my students to say, okay, I'm going to collect 5 cents from each of you every time you make my markers dry out. They have to put the money on the. I'm kidding, of course. Okay, so then from here I have x equals negative 8/3 and x equals 1/3. Will I do this unless I'm forced to? No, the numbers are too big. Why bother? I have an easier method, which is the quadratic formula. If the numbers are like these, no. use the quadratic formula.
I have a question.
Please do.
What if there is no equal 0?
Then it's not an equation. And then I'm not asked to solve. If I don't have this, I'm only asked to factor, and then I have no choice.
Makes sense.
If I have no choice, I have no choice. Yeah, I have to factor. Although there is a way, if I'm asked to factor, there is a way of finding the solutions with the quadratic formula and work your way backwards. Good, very good questions. Excellent questions. Anything else that you would like to go back to before we review those four methods? I only showed the two, and I need to show the other two. Yes,
the
please.
question on the homework
Yes,
where it was,
I'm
it
ready.
Said, it's 2x squared equals 8x plus 3, and it says the exact answer using radicals and I is needed.
Good, excellent. In such a situation, I am asked to solve this equation, and what they are asking us to do is use the quadratic formula. We're not going to do anything else. But in order to use the quadratic formula, remember, I have to have the equation set up like this. If it's not set up like this, I can't use the quadratic formula. So, which means I'm moving everything from one side to the other. All I do is I change their signs. So moving one term from one side to the other, it only changes the sign of that term. Good. So now I'm ready to write the quadratic formula. Negative b. What do I write?
It'd be positive 8, right?
Excellent. Plus or minus the square root of squared. If I see something like this, I do not give any credit. Because negative 8 squared is? Thank you. So please remember, if under the square root you start with a negative number, I'll say oops and move on to the next problem. Very good. Minus 4 times a times c over 2 times a So in order to continue, they're asking us to do to present the exact answer, correct? I think that's what you said.
Yeah, using radicals and I.
Perfect. Okay, so then I have x equals 8 plus or minus the square root of 64. I hope you agree I'm multiplying two negative numbers. Excellent. 4 times 2 is 8. 3 times 8 is 24 divided by 4. So then I continue. 8 plus or minus 64 plus 24 is what? 88, I think. And now I have to be careful because the square root of 88 should be presented as the square root of 4 times 22. Why did I choose 4? I didn't choose 8 times 11. I could have chosen 8 times 11. Why did I choose 4 times 22? 4 is a perfect square. Excellent. So then this answer will be 2 times the square root of 22. So I go back and replace this by 2 times the square root of 22. Any questions?
Are you going to break it down by 2?
Of course, yes. So then x equals 8 plus or minus 2 the square root of 22 over 4. I will separate into two fractions. 8 over 4 is 2 plus or minus 2 over 4 the square root of 22 over 2. Do not try to simplify like this. There will be a terrible mistake. Do not try to simplify like this. This will be a terrible mistake. You cannot simplify terms. But what you can do is separate the fraction. 8 over 4 is this. 2 the square root of 22 over 4 is this, by simplifying.
Is there another way to do that, Rob?
Yes, you can factor out. So you can factor out 2. So you get, 4 plus the square root of 22 over 4, and you simplify it. There's no other way. I prefer this way here because then I can separate. Now here I have to separate again. So 4 over 2 to get 2 and this over this to get that. So it's up to you. Perfect question?
So-
Yes.
Do you take the, yeah, okay. That's gonna be equal to 2. I still don't get it,
Which one?
the first section.
This one?
Yes.
How much is 4 over 8 over 4?
That's gonna be 4, that's gonna be, 2. Wait,
Plus or minus?
okay,
2 simplified by 2 is 1. 4 simplified by 2 is 2.
oh, so you keep the 4,
I have no choice. It has to be separated with the denominator. Yes. So it's 2 over 4 plus or minus this over this.
so basically you're just writing, 8 over 4, and then the other half would be,
2 over 4 with a square root. Yes.
okay,
And I simplify each fraction by itself. Better?
yes.
Perfect. Good. Next question. Anything else before we look at those two methods? Anything else? Okay, so then let's review. There are 4 methods of solving quadratic equations. And you could say, okay, really? Do I need 4? And I will say everyone is different and everyone uses, has a different applicability. That's the reason why we look at 4 methods. Okay, the first one I'm not going to discuss anymore is factoring, unless you want me to. So I factor like we just looked at a problem. I factor and I set it equal to 0 and use the 0 product principle. Would you like me to show another, or are we comfortable with factoring, solving quadratic equations by factoring? What would you say? We need another? We can come back at any point in time if you come across anything. Here's the second method. The second method is called taking square roots. And this is what I said, this is very specific. Very specific. Only when the equation looks like this. And this is the theory. This is not an example. X squared equals k. Something with x on one side and squared. A number on the other side. It can be 0, it can be positive, it can be negative. This is a number, real number. Any number. So we will take the square root or apply the square root at the same time to both sides, of course. The left-hand side should be the absolute value of x. If you remember from taking square roots, for when x is any real number, this is the correct answer. And the right-hand side is the square root of k, whatever that is. The book and everything else, they omit this step, which I think is wrong, but they do omit it. So they immediately go from here, because after you solve this equation, you get 2 options. X equals the square root of k, and x equals the opposite, the square root of k. This is the theory. This is the method we are going to apply. But in applications, it will look much nicer than what you see here. More user-friendly than this. So, let me give an example. Let's say x plus 3, everything squared equals 9. There is no point in expanding x plus 3 squared. And by the way, if I do expand x plus 3 to the second power, how many terms do I get? How many?
3.
Exactly 3. Please remember, we discussed that last Wednesday. Excellent. Thank you. Thank you. So there is no point in squaring, getting 3 terms, moving 9 to the other side and set it equal to 0. There is no point. This is typical for taking square roots. Exactly how we should do it. Take the square root from the left and the square root from the right. The left-hand side, when we take the square root from x squared, x plus 3 squared, we should write the absolute value of x plus 3. Instead, we will go ahead and just write x plus 3. And that's why that's the confusing part. And I will write plus or minus 3 on the other side. But I don't want you to ever think that the square root of 9 is plus or minus 3. It's not. The plus and the minus come from this side, from the absolute value, not from the square root of 9. So I move 3 to the other side, and I do have to separate the solutions. One solution will be negative 3 minus 3, which is negative 6, and the other one negative 3 plus 3, which is 0. So this is a specific type of method, right? It's a method that is applicable only in one situation, and that situation is when I have blah 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 squared and just a number on the other side. If I don't have this particular setup, I will not use this method. So here's another example. Let's say 2x minus 1 squared plus 4 equals why not? Let's do negative 7. Well, I'll say it's the same idea, but this is not cleaned up. What will I do to clean it up first? Right, move it to the other side. 2x minus 1 squared equals negative 11. Now this is good, but still not completely cleaned up. I have one more step to clean it up, or simplify it. I like to say clean up, but you know what I mean. So what do I have to do now? I cannot because it's a power. Careful, by the order of operations, I have to square first before I distribute. So I can do that, careful. Exactly. So I have x minus 1 squared equals negative 11 halves. After these steps, I got this equation back to where it should be so that I can take the square root. So this is specific and typical. Do not square, don't move negative 11 halves to the other side. It's a waste of time. This is what we need to do. The left-hand side will be x minus 1, and the right-hand side, do not conclude that the plus or minus come from the right. They do not. So now what do I do here? I have to write the square root of negative 1, and I have to write the square root of 11 halves. But we know that the square root of negative 1 is, yes. So x equals 1 plus or minus I, and we should rationalize this before I put it in. So the square root of 11 divided by 2 is the square root of 11 over square root of 2, and we multiply by the square root of 2 and divide by the square root of 2. Rationalizing. So this is 1. But the square root of 2 will rationalize the 2 in the denominator. So when you multiply, you get the square root of 22 over 2.
So confused why we did that.
Yes, very good. We rationalize denominators in order to fully simplify an expression. Sometimes, I know it's confusing, but I'm going to say it, sometimes we have to rationalize the numerator for the same reason. But not in this class. You're not going to see that. In calculus, we do a lot of rationalizing of the numerator to find the limit. But here, I don't think you're going to see anything else but rationalizing the denominator. So I was supposed to write here the square root of 11 over 2. So I separate the radicals, the numerator, the square root of 11, the denominator, square root of 2. And now the question is, what should I multiply top and bottom? It has to be 1. You can change the value. If it's anything else but 1, I change the value of the function of the ratio, right? So it has to be 1. But in what form? How will this 1 look like? Well, in order to rationalize the denominator, I need the square root of 2. The square root of 2 times the square root of 2 will be the square root of 4, which is 2. So now the denominator doesn't have a fraction anymore. But now if I have, let's say, 1 over the cube root of 3, I need to rationalize using the same cube root. But what do I need? This time I need to form a perfect cube. And I only have 1 3. I have 1. How many am I missing? 2. So this time I have 3 squared. So the numerator will be the cube root of 9. But what about the denominator? The cube root of 3 times the cube root of 3 squared is the cube root of 3 cubed, which is 3 divided by 3 is 1. So this is 3. So it depends, right? So this is the final answer for our problem. And that was method 2 of taking square roots. So now we have, if you have questions, let me know, please. So now, yes?
Can I have another example?
Of what? Of rationalizing or?
Yes, that's part of the example.
Because here we just subtracted a 4, we divided by 2, and then we took the square root. So you are talking about rationalizing, or okay? So would you like to pick an example, or you want me to pick some rationalizing? That's why I gave these examples. This example here. That's 4 and that's 5. You want me to choose other rationalizing?
Yes.
Okay, just rationalizing, right?
Yes.
Okay. So let's say I have 1 over the 4th root of x squared y cubed z. Obviously, I have to have the same root. Let's assume everything is strictly positive. So then what do I do? What do I rationalize by? So obviously it has to be the same index. But what do I need? This time I need to form a perfect what? Is it perfect square? Is it perfect cube? Is it perfect fourth? Is it perfect fifth? Perfect fourth. So in order to form a perfect fourth, I need how many of x? How many of y? How many of z? Okay, so then tell me what I'm missing and I'm going to put it in. Very good.
Z to the fourth.
Careful. Z to the third. Copy the base and add the exponents. So when I multiply x squared by x squared, I copy the base and the exponents. I get 4. When I copy the base x of y, I add the exponents and I get 4. I copy the base for z, add the exponents and I get 4. So now when we multiply the two radicals in the denominator, what do we get? I shouldn't even calculate anything. I should just put the answer in. Say it again. Okay, when we multiply these, I get the 4th root of what?
X, Y, Z.
Of course. X to the 4th, y to the 4th, z to the 4th. That's why we chose those quantities, to get x to the 4th, y to the 4th, z to the 4th. 4 over 4 is 1, 4 over 4 is 1, 4 over 4 is 1. So I just copy the numerator. There is nothing else. I can't do anything to the numerator. Better? you're not going to see such an extensive type of problem.
Better.
No. I just wanted to give you the idea. So, for example, if I need to rationalize the square root of 7, what will I multiply by? This is what you're going to see. I went to a little extreme there just to give you the idea. What do I rationalize by? What is the index here? I don't see the index. Exactly, it is 2. The lowest possible index is the square root, which is 2. So then I have to multiply by the square root, but how many sevenths am I missing? 1. Okay, and that's it. So this is a square root of 7 over, obviously, 7. This is what you're going to see. Not better? Okay, so this was method number 2. So method number 1. Method number 1 is factoring. Method number 2 is very specific. Very specific. It only works in these situations. Something like this or something like this. Only when I take square roots and I solve. Careful. If I have x on this side, I cannot take the square root. So this has to be something with x, definitely squared, and whatever number, not x on the other side. So this is very specific. Now the third one is called completing the square. And the question is why? And the answer is really not useful here. It's useful for something else we are going to look at later. It's not for this. But it kind of works for solving quadratic equations. However, it alone will not do the job. You'll see what happens. So complete the square is not my favorite method to solve quadratic equations. You will have one quadratic equation to use complete the square on. You'll be forced to use the method, otherwise I will never ever use it. So here's the idea. Let's refresh our memory on this that we looked at last time. When we square a binomial, how many terms do we have to write? And what are they?
3.
Yes,
A squared times 2 times A times B.
but plus.
Yeah.
Correct.
Plus, 2.
Very
A
good.
times B plus
Excellent.
B squared.
Excellent. And this one is the same thing, but with minus. Notice that this is always plus. If this is plus, the middle is plus. If this is minus, the middle has minus. But this is always positive. Why am I reviewing this? Because we are going to use this piece. And you'll see in a moment how and why. Okay. So complete the square says this. This is, again, the theory. The problems themselves will be slightly easier than what you see right now, but I just want to give you the background. So any quadratic expression, can be presented as a perfect square plus a number. Of course, this number can be positive or negative, any number. It can be any number. Of course, it's going to be a specific number in this case, not just any number. It's not this will not work for any number, and it will not work for any binomial, right? So I'm interested in showing you that this expression can be written like this. And what does this mean? In a moment, you'll see. So I'm looking only at x squared plus 4x. And I will say, well, these two terms come from a binomial squared. So if you compare the x squared with 4x, you should be able to come up with a third term here. What should the third term be? So exactly. So excellent. Okay, perfect. So x plus 2 will be, when I square it, how many terms will I get when I square this? Very good. The first term squared plus 2 times the first times the second plus what? Which is plus 4. So then plus 1. So this piece is this, and the number I was talking about is 1. We're not going to do this. You're going to see some problems in my lab math like this. Yes, please. Go ahead, please. Any question, anytime.
So basically, when you got the +1, it was just the
Because I had the 4
4
plus 1.
so it gets to the
Exactly.
5.
Exactly.
Okay.
Exactly. So you may encounter some problems like this. So I claim that this is basically x plus 2, and this number is 1. That's my claim. Okay. And now let me show you on examples, and you'll see it's easier than what we just encountered. Okay, so let's say we are asked to solve this equation. Using completing the square. We are forced to use completing the square on this problem. What do you think I'm going to do first? I want 4 out of the way. I move positive 4 to the other side, becomes negative, and 10 minus 46. The method of completing the square, 4 steps of completing the square. Step number 1, identify the middle coefficient. So let's take a look. I have the leading coefficient, I have x squared, I have the middle coefficient, and I have x, and I don't care about anything else. So what is the middle coefficient here? Excellent. Perfect. Step number 2. Divide it by 2. Now I know you're going to ask, why by 2? I have this middle term. I have the first term. If I divide this quantity by 2, I will find what I'm interested in as the second term. That's why I'm dividing by 2. I have the first term. I want to find the second term, but I have to divide this quantity by 2 in order to find the second term. So please divide negative 6 by 2. Step number 3. Square negative 3. Final step. Add 9 to both sides. To complete the square. And complete the square if that's what you want to write. And or to complete the square. So let's review the steps and then we'll proceed. Identify the middle coefficient, negative 6. Divide negative 6 by 2. Square negative 3. Add 9 to both sides. But I have to add 9 exactly like this. Positive 9, positive 9. If I omit to add it to one side and add it only to the other, I change the equation. Adding 9 pounds to a balance, adding 9 pounds to both sides of a balance, it will not change the balance. If I only add it here, it will tremendously change everything. Okay, so now the new equation becomes x squared minus 6x plus 9 equals 6 plus 9. The right-hand side, obviously, it's not a problem. Can anyone, and everyone should be able to give us the left-hand side factored? X minus 3, everything squared. And This is what we did. It took us a long time. It's not a friendly method at all. But we managed to complete the square. So let's go back for a moment. This is what we started with. And this is identical. But now you can say, okay, you're done. No. I completed a square and I still didn't solve. But now it's exactly in the typical format in which I will apply that specific method, which is taking the square root. So I don't like this method for two reasons. Number one, it's way too long. Number two, it doesn't solve the problem. You have to go back to the previous method, right? So we take the square root. So we get x minus 3. Remember, plus or minus do not come from the square root of 15. So then x equals 3 plus or minus the square root of 15. So complete the square alone cannot do the job. However, the method is very useful for something else at the end of chapter 2. So I'm going to go back to it when we finish chapter 2 and refresh our memory on this method. Do we need another example?
Can you just tell me why you got x minus 3? How'd you get that? Like,
First of all, the minus. So, from here.
right. Yeah, I follow. Okay. Okay.
So I had x squared minus 6x plus 9, which
You're
can be
right.
replaced by x minus 3 everything squared.
Okay.
Very good question, actually. Because it gave me the chance to show this again. Very good question. So now when you expand this, if you want to check, the first term squared minus 2 times the first times the second plus the second term squared. And the last method, I'll come back with more examples if you want to. So the last method is a quadratic formula, which we have practiced already.